Okay, this lesson is graphing inequalities. And so we're going to look at some inequalities that have a variable and a number in them and learn how to represent those on a number line. Let's see if I can focus that just a little bit better. There we go. It's trying. All right, so we're going to start with the inequality n is greater than 2. So I want you to think in your heads which numbers on this number line would work in here. Which numbers are bigger than 2? Think back to elementary school. This is the alligator mouth. It eats the bigger number. So we want you to think about all the numbers we could put in for n that would be bigger than 2, because this is n is greater than 2. Okay, so you should have come up with numbers like 3 and 4 and 5 and 6 and 7, and all of the numbers out here are bigger than 2. So 3 would be a solution, 4 is a solution, 5 is a solution, 6.5 is a solution, 8 over here is a solution, 100 would be a solution. So what we want to do is represent all of the solutions for this inequality on the number line. How we do that is we start at 2. We are not going to put a point at 2. We're going to put a little circle that represents a hole in the graph. 2 does not work because 2 cannot be bigger than 2, but it's a starting point. And then we're going to shade everything to the right of 2 and put an arrow showing that it goes on forever. All the numbers bigger than 2 go out here forever. Now the reason why we start at 2 is because you could get infinitely close to 2 and have some numbers that are bigger. Like I could have 2.1 in there or 2.0008 in there. And those are both bigger than 2, but it's hard to kind of get that close with our graph without making it look like 2's included. So that's why they put this little circle there. 2 is not included, but it's a starting point for all of these numbers that are bigger than 2. Now, a really cool thing happens when you see this greater than sign with the n on the left-hand side. This greater than sign looks like the end of this arrow. See how this points to the right and this points to the right? That's kind of a cool deal, and that's where the symbol comes from. It's an arrowhead showing you that numbers on the right are bigger. Okay? We'll come back to that a little bit because they will switch some things up on us and we'll have to think about it. Let's take a look at number 2. So this says B is less than 4. 4 is bigger and B is less. So we want to think of all the numbers that are smaller than 4. So if we think about that, here's 4. All the numbers to the left of 4 would be smaller. Things like 3, 2, 1, 0, -1, -2. -5.5 would be smaller. -10 would be smaller. So everything from 4 to the left is what we're looking for. So since this is less than, I'm going to put a circle at 4. We are not filling in the circle because 4 cannot be less than 4. 4 is not part of my solution. But that shows us where to start the arrow. And so this would go forever out this way. And we put an arrow on the end because it's hard to keep drawing forever and ever. It would keep going to -100 and -1,000. And there's so many infinite number of numbers that are smaller than 4. Now take a look at this less than symbol. It looks like this arrowhead, and that's where the symbol comes from, if you didn't know that. It's an arrowhead showing all of the numbers to the left on the number line are smaller than 4. Okay? So we have a couple of symbols that we've looked at so far. We're going to add some new ones that you may not have seen before. Let's take a look at number 3. If I have a greater than symbol with a little bar underneath it, what that means is greater than or equal to. And what that means is I could put 3 in here, and it would be a solution. 3 is equal to 3. So on the graph, 3 is equal to 3, so I can put that as an actual point that's filled in instead of just an open circle. And then the greater than piece means we're also going to include numbers that are bigger than 3. So things like 4, 5, 6, 7, 8, often to infinity. And we shade in all of those numbers to show that all of these numbers to the right of 3 are bigger than 3. So the difference on this, when they put that little bar, it's like part of an equal sign. It means that 3 gets to be included on the solution. It's either 3 or it's bigger. And then this arrowhead, again, goes with the greater than sign. It's pointing the same direction, so that's kind of cool. Okay, let's take a look at number 4. So now I have it pointing the other direction, which means less than or equal to. So since it has equal to, when we get to 2, we still make the circle, but we fill it in. So when you see this bar, we're going to fill that in because 2 is equal to 2. It's part of my solution. But then we're going to have other numbers that are part of the solution, other numbers that could be in to make this true, that would be less than 2. So we think about numbers that are less than 2. Well, 1's less than 2 and 0's less than 2, and every number to the left is less than 2. So we're going to make an arrow this way and put an arrowhead on it that shows here are all of the numbers that make this true. The numbers that are less than 2 are over here on the arrow, and then equal to 2 is where we filled in this point. So if you don't have that equal to sign, you leave the point open. It's sort of like a little hole that just starts your arrow. And then if you have the equal to bar, you're going to fill that point in. All right, let's do some tricky ones. So on number 5, I have -3 is less than x. On all of these examples up here, we had the variable on the left-hand side. When they move the variable to the right-hand side, it becomes a little tricky. But we can go ahead and start our graph. I notice I do not have a bar underneath. So I'm going to go to -3 and go ahead and make my circle. And then I just have to figure out which sets of numbers are going to make this true. So I'm going to pick numbers from either side and see which ones make it true. So this side are the numbers that would be smaller, like -5. So if I had -3 is less than -5, that wouldn't be true because -5 is actually to the left. This one's actually smaller, and you'd have to go the other way. So that's not it. We could try a number from over here. Let's say I want to try +1. So I could try -3 is less than +1. Well, -3 is on the left, and +1's on the right, and all the numbers on the right-hand side are bigger. That's true. So I know that this side of the inequality is the numbers that are going to make it true. Now I think it's a little weird with the negatives sometimes to figure that out. So I'm going to show you another trick. We can flip-flop this. I can put x on the left and -3 on the right, but the alligator is eating the x, so I want to make sure that's still happening when I turn it this way. And if you put the x on the left-hand side, the greater than symbol goes with your arrowhead, and that helps you figure out which part of the graph to shade. Do I shade left from the point or do I shade right? But you can always use those test points, and that's a good way to think of it. These are all the numbers that are going to make this true. If I put 6 in there, 6 is greater than -3, that makes it true. Okay, so let's take a look at number 6. Let's try turning it around this time. So let's put p on the left and -4 on the right. And the alligator is eating the -4. So I'm going to turn that around. And then we keep the equal to symbol there. When I have that equal to symbol, that means when I go to -4 to start my arrow, I fill in the point because -4 is part of the solution. If I put -4 in there, -4 is equal to -4. And that's what that bar means, is equals. And now that I have this turned around, this becomes a less than sign, and it points me the direction that I want to put my arrow. So I can shade to the left and put the arrow. I can also try test points. If I put -5 in for p, I'd have -5 is less than -4, which is true because it's to the left of -4. If I were to try, you know, a number like 7, 7 would be bigger. If I put 7 in there, that's not going to work because 7 would not be less than -4. So those test points are a good way to figure out whether or not you have the arrow going the right direction. But the symbols are actually arrowheads, and I thought that that was kind of cool. I didn't learn that in school. I learned that later. And so that's just a nice way to kind of see where these symbols actually come from. All right, so we're going to go backwards when we get down to the bottom part, and they're going to give us a graph, and we're going to write in an inequality. Now the fun part of this is you get to pick whatever letter you want. So on number 7, we have a circle at -6, and then it's shaded, you can just barely tell, off to the right. So I'm going to pick A for Amanda. It doesn't have to be X. It could be any letter you want it to be. And it's going to the right. So this arrowhead's going this way. So my little symbol is going to go this way. This is all the numbers that are bigger than A. That's bigger than -6. So I'm going to say A because all of these numbers out here represent A. Okay, all these numbers out here represent A. That is bigger than -6. And I do not put a bar underneath because the circle is not filled in, and that's my answer. And you can use any letter that you want here. Just make sure you've got the greater than -6. Okay, let's look at number 8. So number 8, I notice that the point at -3 is filled in, and that automatically lets me know that I'm going to have an equal sign. So let's use a different letter. Let's just go ahead and use X on this one. The arrow's still going to the right. Here's my arrowhead. So I'm going to make my inequality symbol look like that arrowhead. It's pointing to the right. So X is greater than or equal to, because if I see this point at -3 is filled in, so we're including that point in our solution. And then in -3. So X is greater than or equal to -3. All right. Let's look at some that point to the left. So down here on number 9, I have my point at -4, and it's going to the left. So let's just pick a random letter. Let's say we want to use S. It doesn't matter. This is going to the left. So my solution is all of the numbers that are less than -4. So S represents all of these numbers, and it's less than or equal to, because the point's filled in, it's included, so we have an equal to -4. So when the point is filled in, you put this little bar underneath, and it's half of an equal sign, and it means that -4 being equal to S is part of the solution. All right, let's take a look at number 10. So let's pick another random letter. Not random, I'll use P for Philomore. And then I notice this is going to the left again, so I'm going to have a less than sign. I will not have an equal to sign, though. They left this point open. It's not included as the solution, so I don't want it to be equal to -3. I just want the numbers that are less than -3. So P is less than -3 is my solution. What I want to do at the end of this lesson down below is to do a little bit of a summary, okay? So I'm going to zoom out just a little bit, and we'll put a little summary here at the bottom. So what we could do is we could say less than and greater than. You're going to have the open circle. Less than or equal to, greater than or equal to, you're going to have the closed circle. So this is a point, and this is sort of a non-point. It's sort of a starting place for your arrow, but we're not including the number. And so we could just make a little table out of this and show that that's how we're going to do things. And then these symbols, if the variable is on the left-hand side, it shows you the direction. But, like we saw before, sometimes you might have to turn it around or use a test point to make sure that you have the right set of solutions.